Now a spherical shell with uniform charge distribution. So if we have a spherical shell with uniform charge distribution, how to go about the potential? So we have already seen that the electric field at a point outside and at a point on the surface of any spherical shell with uniform charge distribution is equal to what? The electric field obtained by considering just that the entire charge of the shell is concentrated at the center. Say this is the center, so whole of the charge is concentrated here. Again, any point which is outside or at a point on the surface, we assume that whole charge is inside. Okay, so we have obtained the electric potential from electric field. We know that V is equal to minus integration from infinity to R E dot dr. And for electric potential also, this entire charge, this we can consider to be concentrated at this or concentrated at the center of the shell. So the potential of a point which is outside, say here, and at a point on the surface, say here, of a shell having charge, say Q, and the radius, say from this point to this point is R, is given by what? V equal to 1 by 4 pi epsilon naught Q by R, and this R is different. This R is the radius of this shell. This R is the distance. So this R is the distance of this point from the center. It can be like this. It can be like this. So this is the distance from the center of the shell. And also, we know that the electric field inside the shell is zero, because the point of discussion is the spherical shell with uniform charge distribution. It's a spherical shell. So the electric field inside this is zero. So during the motion of unit positive charge inside the shell, there is no work done. There is no work is required to be done. So the potential at all points inside the shell, they will be having the value which is equal to the potential on the surface. So all these points will have potential which is equal to the potential on the surface. So we can just write this. We can change this R with capital R, because at surface, this is R, this is the radius. So we can write V equal to 1 by 4 pi epsilon naught Q by R, right?